Hi, so in this video, we'll look into some basics of MATLAB and some programs to start with, which will help you in understanding the basic concepts of MATLAB programming. So when you click on MATLAB, this GUI is appearing before you. So you can see you have a workspace, you have command window, and then you have this directory where you can see all the files that are stored. So to start with workspace is the place where all your variables that you initialize in your program or that you use in your program are stored. And coming to the command window, so command window is the place where you can execute some short programs, observe the results. So let us just check some example. Say you have a variable a which is given by 2, and then you initialize a variable which is given by 4, and say I wish to know what is a multiplied by b, and you would get the result as 8 in the command window. So you can do some calculations, you can observe your output, you can look for some theoretical calculations of your program in this command window. And obviously you can also do programming in your command window, but I will not suggest you to use the command window for programming, because you may get the output in the command window but then it would not be saved. So once you close MATLAB after using command window, you will find that the program that you have written has disappeared. So it is not possible for us exactly to store the program that we write in the command window. So as you can see, we have used some variables a and b. So earlier our workspace was empty. Now if you see, our workspace has these variables a, b and the answer. So the variables that we use in our program are stored in the workspace along with their value. So this is a brief introduction to workspace and command window. So you would be wondering that I have told you not to write the program in the command window. Then where do we write the program? So you have to write the program in editor. So where do we get the editor from? So you can see on this top left corner you have new option. So click on new and just select a script. So when you select a script, you can see that your editor has opened. So this editor is the place where we'll be programming and analyzing our results. So to start with, today in this video, we'll see how to plot a basic signal. So whenever we are trying to write a program in MATLAB, I suggest you to start the program with these initial commands. So you may wonder, what does these initial commands mean? So to be clear, CLC. So CLC clears our command window. Then you have clear all. Clear all clears our workspace. So these are used, say you have multiple programs that you want to write and you would use same variables in most of the programs. So in order to avoid confusion, we make sure that before we run a program, we clear the command window and we clear the workspace, so that MATLAB doesn't get confused if you use the same variables in multiple programs. And what is the use of this close all? So when you go for close all, say you have already typed a program and you have executed it and you have got some result, and you have made some changes in the program again and you wish to execute the program again. So if you use close all, the windows that have popped up in the earlier case when you have executed the program will get closed. So you will not have any confusion as to the output refers to which particular program. Right. So now let us, in this video, let us see how to plot a basic sinusoidal signal. So we know that a sinusoidal signal mathematically can be represented by a sine omega t. So there are three variables that we will have in our expression. One is the amplitude, the other one is the frequency, and the other one is the time axis. So now I'll start with the time axis. So I'll initialize my time axis to start from say -10, and I wish that my sinusoidal signal should end at 10 seconds. So now in this case it is important here to mention what is the step size. So if you look here, I have written a command which tells you t is -10 is to 0.1 is to 10. Now this means that your time starts from -10 and it ends at 10, and the step size is zero point 0.1. That means whenever you're plotting a sinusoidal signal, the values are taken at -10, -9.9, -9.8, -9.7, and so on till +10. So you would have large number of values for which your sinusoidal signal would be plotted. And we need to make sure that any command that we write in our program should end with a semicolon. Now let us say define the amplitude. So I define my amplitude by a variable a, which is given by say 2. Right. Now I wish to generate a sinusoidal signal with a frequency of say 5 Hertz. So I have defined my frequency here, and the frequency variable is represented by f, which is given by 5. Now we know that omega is equal to 2 into pi into f. So we write or we define a variable omega which represents the angular frequency and which is given by 2 pi f. So we write the same thing in MATLAB, 2 multiplied by pi multiplied by f, and MATLAB understands that pi represents pi. Now let us denote our output sinusoidal signal by a variable y. So if I wish to represent my sinusoidal signal by a variable y, I define y is equal to a multiplied by sine of omega multiplied by t. So this is what a very basic command of defining a sinusoidal signal looks like. So you have a sine omega t, where a is the amplitude and it is multiplied by the sinusoidal function, and you have sine of omega t. So omega and t, there is a product in between. So now that we have defined our sinusoidal signal, now let us try to plot this sinusoidal signal. So whenever we are trying to plot any function in MATLAB, we use the command given by plot. So when I mean by plot, I have to use plot x comma y. So what do we have on x-axis in this particular sinusoidal signal? So my sinusoidal signal is always plotted with respect to time. So on x-axis I have time. And what do I have on y-axis? On y-axis I have the amplitude or the sinusoidal signal. And here the sinusoidal signal is represented by the variable y. So I use plot of t comma y. So please make sure that whenever you are writing plot command, you should denote the variable which comes on the x-axis, then followed by the variable or the function which you are going to plot on the y-axis. So once we are done with plot, let us try to give the labels to the plot. So the label commands are given by x label. So you write x label, open brackets, and what do you wish to have on the x label? On x-axis we have time. So the units of time are seconds. So I write the same thing in quotes. So time in seconds, and I close the quotes and I close the parenthesis. Then I do the same thing with y label. So on y-axis I write the amplitude. So I write the same thing in quotes, amplitude, and say I can give the units as volts. Close the quotations and close the parenthesis. And I can also give the title to the graph. So this title represents a sinusoidal signal, right? So with this, we have just written a MATLAB program to plot a very basic sinusoidal signal. So now before we run this program or execute this program, let us try to save this. So I save it in the directory where my MATLAB is installed. So please do not save the MATLAB files by any default functions which are defined in MATLAB. So that may cause some error. So probably I save with my name. Right. So I have saved this program. Now let us try to run this program. So we click on this run option which we are able to see here on the top, and when I run, so you can see that I have got a signal, but this does not represent a typical sinusoidal signal. So the reason for this is the step size that we have mentioned here. So the step size that we have mentioned here is zero point 0.1, which is typically a very small value, which is typically a very large value. So if I have to reduce this value, maybe say I'll take it as 0.01, and now I execute this program. So now you are able to see that I have got a sinusoidal signal, but I need to zoom it a bit to observe it very carefully, and maybe I can reduce the frequency to say 2 to visualize the graph in a clear manner. Yes, so you are able to see this. And if you want to reduce the time axis also, we can reduce it. So rather than making it from -10 to 10, we can go to -5 to 5. And when we execute this, yeah, so we are able to see a very nice graph of a sinusoidal signal, which is starting at whose amplitude is starting at -5, and then it is ending at +5. And you are able to see that we have this title, and then the axes are labeled as we have mentioned. Now before you continue with this, say if I wish to show you, say with a frequency of 1, if I change the frequency to 1, yes, so you can see a more clearer graph. Now if I wish to do some editing on this figure, so we have this edit option, and then we click on this figure properties. Now once we click on this figure properties, I just right click on this particular sinusoidal signal, and when I right click, I would get different options, like we can change the color. So you select on color and you use a color of your convenience that you wish to, and we can have the color change. Then if you want to have since this figure looks little thin, if you want to increase the thickness, go to a line width of 3, and we can see that the thickness of this figure has increased. You can also explore other options, and some of the commonly used options are, you can also use the style of the line as dots and dashes. So there are various options. Once you click on them, you can come across these options of color, line width, and line style, and then those can be changed as per one's convenience. Then typically we also try to make sure that the axes that we have are clearly legible to us. So we just right click on these axes and we click on font, and we bold them and then go for a higher font, so we can see that this is clearly readable to us. Again, we do the same thing for the Y label also. We just bold it and increase the font, so we can see that the X and Y axis titles are also clearly legible. So these are some editing tools that you can explore when you get the output. And once you get the output, if you wish to report this output anywhere, then you can just click on this file save as option. So when you click on save as, you need to select it as any one of the required formats. Most commonly used formats are JPG or PNG. So you can save it as an image, and then you can take those figures to wherever you require, where you need to report them. So this was one very basic example of plotting a sinusoidal signal. Now, uh, if you have checked this signal, so we can see that this signal is a continuous time signal. So by continuous time signal, we mean that the signal is defined at each and every instant of time, right from -5 to +5. Now, if I wish to plot a discrete time signal, so what do I do if I wish to plot a discrete time signal? So if I wish to plot a discrete time signal, I change this command of plot to stem. So when I change this command from plot to stem and I run this program again, so you can just observe the change, but because we have a large step size, let me slightly increase the step size so that you can have a clear interpretation. Yes, so furthermore increase maybe 0.1. Yeah, so you can see that now this is representing a discrete time signal. So what do we mean by discrete time signal? So the signal is defined at discrete instances of time. So here between say -4 and -3.8, the signal is not defined. So the signal is defined at discrete intervals or instances of time, and that is why we call this as a discrete time signal. So you can also plot a discrete time signal by changing this plot command to stem. Now let me introduce you to a new command where, say, I wish to plot both continuous time and discrete time signal in the same figure. So what do we do in that case? So in that case, we have something called as subplot. So what do we mean by this subplot? So let me just show you what do we mean by this subplot. So in this subplot, I want to plot two signals, one in continuous time and one in discrete time, on the same figure. So I want to plot them one below the other. So in that case, I would have two rows. So I write 2 here. Then I have one column. So I would write 1 here. And then I want the first figure to be a continuous time signal. So now I write plot t comma y, and please note that for every plot you need to give the xy label and the title separately. So in this we change the title sinusoidal signal in continuous time domain. And now I write the another command subplot 2 1 2, and then I have this stem as it is. So what do we mean by this? So in the subplot 211 and subplot 212, let me just explain it with the help of the figure that we get. So say my second figure is the sinusoidal signal in discrete time domain, and let me just run this program. Yes, so as you can see on the same figure we have got both the continuous time and discrete time signals. Now if you see, we have two rows in this figure, so that represents the first two in this subplot. Then we have only one column, so that represents the number 1 in this subplot. And my first figure is representing a continuous time signal, so I write for this subplot 211, I write the command plot. And my second signal is representing a discrete time signal, so I write stem for this subplot 212. So my first figure is a continuous time and second figure is the discrete time. So that is why we are using this command subplot, where we have two figures in the main figure. And you are free to explore the different properties. Say you can make this as 1 2 1 and 1 2 2 also, where you have one row and two columns, and you can see what is the change in the output that you get. So now you can see that we have two columns but one row. So that is why we have written subplot 121 and 122. So the first number represents the number of rows, the second number represents the number of columns, and the third number in the subplot represents the figure that you want to plot. So I hope this is clear, the use of subplot command. So in this we have seen how to plot a basic sinusoidal signal in continuous time and discrete time domain separately and also on the same figure. Now say I wish to plot a sinusoidal signal and a cosine signal. So how do we get a sinusoidal signal and cosine signal? So I now use another variable z given by say a into sine of omega t, I'm sorry, omega t plus say 90. So we have a 90-degree phase shift. And now I would plot the second signal to be t comma z, and I would prefer two row one column format, so I'm going back to the older one rather than one row two column. So I have subplot 211, subplot 212. So the first figure would represent the variable y, which is a sinusoidal signal. The second plot in the subplot would represent the variable z, which is defined by a sinusoidal signal with a 90-degree phase shift. So let us change the title also. So now in this I give the title as cosine signal, and now I run this program. Yes, so you can see that in this first figure represents a sinusoidal signal and the second figure represents a cosinusoidal signal. So you can see that our figure is not that smooth. I can see some edges and flat tops. So to avoid this, we try to reduce our step size and make it to say 0.01, and now when I run we can see that we get a very smooth figure. So the key point to understand in this is if you wish to have a smoother figure, you have to use a step size which is as small as possible. So here we have plotted a sinusoidal and cosinusoidal signal, one below the other on the same figure. Now let me also introduce you to another command, say where I don't want to use a subplot. I want to use the uh, command called as hold on. So what does this hold on do? Let me show you. So with the help of this hold on, we can plot multiple figures on the same figure, and I have just used hold on command, and let me just run this program. Yes. So now if you are able to see, we have just one figure, and on this figure we have both sinusoidal and cosinusoidal signal on the same figure. So we have not used subplot command. Instead we have used hold on command, where on the same figure we have two different functions that we have plotted. But now, as a beginner, we understand which is a sinusoidal signal and which is a cosinusoidal signal. But say if you want to clearly specify in your figure as to which one is a sinusoidal and which one is a cosinusoidal signal, then let me also introduce you to another command in MATLAB, which is given by legend. So let's see what happens when I use legend. So when you are plotting multiple figures on the same main figure, we use a command called as legend, and you have first plotted variable y, and y represents a sinusoidal signal, and then you have plotted the second figure that you have plotted is z. Z represents a cosine signal, So I then write cosine signal in quotes separated by a comma in this command called as legend. And when I run this, you can observe now it is very clear for anybody to read that the blue color graph represents a sinusoidal signal and the red color curve represents a cosinusoidal signal. So that is how we make use of this command legend and hold on. So let me quickly summarize what we have done in this video. So we have used MATLAB to plot a very basic sinusoidal signal, and we have used multiple functions to explore these functionalities of MATLAB such as subplot, hold on, and we have seen how multiple figures can be plotted on the same figure. So thank you. See you soon.